So for this demonstration here, what we've got is we have an example of a tube that has a closed end here, which I filled with water, and an open end, which we can see because I can stick my finger in there. Now what I've got here is a tuning fork. This tuning fork has a frequency of 480. Now when I put it over top of this column, I don't hear much. How long would this column have to be if I wanted to be able to hear sounds? So in other words, what's the first harmonic and what's the second harmonic? Take a minute and try that out and then come back.
So what we're going to do is we need to write down that the frequency here is 480 hertz. Now we know the formula is going to be speed is equal to frequency times wavelength. The thing is, we only know one of these things right now. So we need to go ahead and figure out the speed. Now I'm doing this out in the air, so it's going to be the speed of sound, which is equal to 332 plus 0.6 times the temperature in this room in degrees Celsius. I just went and checked the temperature, and the temperature here is going to be 22 degrees Celsius. So if I go ahead and I plug this into my equation, I'm going to end up with 332 plus 0.6 times 22. And what you're going to see the answer is equal to 345.2 meters per second. We now have two pieces of information that we can plug into our equation here. So therefore we're going to end up with 345.2 is equal to wavelength times 480. And when we work that out, we see that the wavelength is going to be equal to 0.719 meters. So there's our wavelength. Now what I was asking you for in the video is for the first and second harmonic. So let's go ahead and take a look at what those formulas are. So for the first harmonic, the formula is length is equal to 1/4 of the wavelength. And for our second harmonic, the length is equal to 3/4 times the wavelength. So now we're going to go ahead and we're going to plug these values in. So 1/4 times 0.719 and 3/4 times 0.719. And what we find is that our two answers here are equal to 0.179 centimeters and 0.539 centimeters, so 54 centimeters. Now let's go back and see if we can actually get this to work.
So at this point, I'll assume you went ahead and did the calculations, and you know for the first harmonic, the answer is around 18 centimeters for the length of this column. So if I hit this right now, you might hear a really high-pitched sound, but you're not going to hear 480 hertz. Now what I'm going to do is I'm going to go ahead and I'm going to adjust this, so it's just under 18 centimeters. And what you'll see now is when I put this over top of the hole, it's much louder. If this column was just a little bit shorter, still audible, but let's take it way out of the range. All you hear is the high pitch, because that was the first harmonic where we heard that sound. Now our second calculation said the second harmonic's around 54 centimeters, 53.9 to be exact. So let's go ahead and let's measure that out. Got it there. Yet again, what you're going to hear that's the sound at the second harmonic.